C.A.T. software is based on AutoCAD and does not require third-party software. AutoCAD is the present standard in the design and construction of today's building projects. To start your project, it is important to have all the information available for architectural and structural elements within your project, preferably in AutoCAD format or DWG files. Here we see the layout for our project. We have added the bearing walls and structural steel for the roof system above. This is to see the space available over the ceiling for our project. We are turning on the layers that we have created, exterior walls, and the bar joist system. This side elevation will give us an idea of the space available. The plan view will give us joist spacing. With our project floor plan in place, we will begin the design of the fire sprinkler system using the C.A.T. Sprinkler Professional's intelligent software solutions for the construction industry. In this demonstration, you will see how you can rapidly complete your design and print parts lists generated in a format of your choice upon completion. You will see how the software will perform all calculations for the fire sprinkler system by automatically reading all data from the drawing. To start the Sprinkler Professional, go under the C.A.T.S Commander and find under General the project data information required for setting up your project. In the Preferences, you can set up the software to perform the calculation as per Hazen-Williams or Darcy-Weisbach. You can also choose the type of pipe you are using and other specifications for your project, such as ceiling height, coverage of fire sprinkler heads, distance between heads, and distance between the heads and the walls. After establishing the design criteria, you can have the heads automatically placed in the room by selecting the 4 interior walls of that room. The software will calculate the coverage area for this room and place the heads. Automatically, a window opens to show the information for the room and the sprinkler head selection. After selecting the type of fire sprinkler head from the database and the direction arrow specifying direction of flow for that area, the software places the quantity, spacing between, and elevation of the heads. Once all the sprinkler heads are in place, the system automatically assigns numbers to the heads. In the C.A.T.S Commander under Pipelines, you find Draw Pipes. This is similar to the AutoCAD function line. Begin by starting at the floor and giving the line an elevation in Z direction. Then move the line in X direction. Finally, move the line in the Y direction. You have now established the center line of a fire sprinkler main. You are now ready to select the location on the fire sprinkler main line where you would like to place the branch pipes supplying the fire sprinkler's heads. Using the Snap Nearest command in the C.A.T.S Commander, you can draw the branch pipe center line alongside of or above the fire sprinkler heads. After the layout is completed, you connect the sprinkler heads automatically to the pipes by highlighting those sprinklers that are going to be connected. A window appears for you to confirm the type of connection that you would like to use for that area. As you can see, the center room to the right has not been connected. For this space, we will use the Draw Automatically Select Type command. You will be prompted to select the branch line that you will connect to. You will then be prompted to select the first and last sprinkler head to be connected. In this instance, we select 24 through 32. The type of connection once more must be selected. We will select the third, which is a bottom outlet to the fire sprinkler head. Select OK, and the piping is placed on the drawing. After the layout is completed, you can delete the pipe ends that are not needed. Next, you define the operating remote area for the hydraulic calculation. The interconnecting pipe sections are numbered automatically. Prior to the hydraulic calculation, you have to recheck the starting values. You can modify or select the starting values indicated. Select OK. You will now see the piping lengths, fittings, type, and quantities of the fire sprinkler heads. Calculation data may be inserted onto the drawing at the location where you would like to place it. You can also export the calculation results to an Excel spreadsheet. Similar to a layer tool, you may want to select information on the drawing that is not required for submission to local building authorities in the application for a fire sprinkler permit. For example, you may want to hide the numbering of the fire sprinkler heads, fabrication lengths of pipes, etc. Conversely, your fabrication facility would not necessarily need the hydraulic calculations. In the C.A.T.S commander, select the 1D to 3D command. The software database defaults will appear. You may change the values or select OK if the default values meet your design criteria. Highlight the section of the drawing that you want converted to 3D, generally the entire space. You are prompted to select the radius specifications for the elbows you are using. The default selection will be a standard radius 90. Choose OK. After the drawing is completed in 3D, you have the information for all the fittings and pipe. You are ready to send the order to your production facility or your automated machinery for fabrication. With C.A.T.S software's tools and layer management software, you'll find yourself moving rapidly through the design phase of your project. You are prompted at each stage of the design to select the layers that are established for you to implement into your design. We are now going to design the duct system. In the C.A.T.S commander, under Ventilation, click on the drop-down menu for Ventilation Pilot, pulling up the bottom menu. All the components to design your ventilation project may be selected here. We select Ceiling Diffusers and select the first diffuser in our database. In Attributes, we can change our CFM values, pressure loss and dimension, type, material, etc. The command bar is asking to select Start Point. Next command bar is asking for the Z elevation bottom edge. Our elevation height here is 96 inches. The software is asking to select the layer management for all diffusers. Our first diffuser is now placed. In the Array window, we have set up a pattern of 2 rows and 3 columns. The other diffusers for the room are now placed. Using a Move command, the diffusers are moved within the room. We are now copying the diffusers in this room to place elsewhere. We will now place the balance of the diffusers. The placing of diffusers you can see is being accomplished through the standard AutoCAD commands. After the diffusers are in place, under the C.A.T.S commander, under Edit Duct, we select Properties. The window appears with all the properties that can be changed, such as description, CFM, and the diffuser pressure drop. This allows the user to establish data based upon the air distribution devices of their preference. After all diffusers are in place, in the C.A.T.S commander under Components, we are looking to select a fire damper. A window appears showing a fire damper. Here we can insert dimensional data for the device, length of sleeve, etc. We're going to place the fire damper 12 inches from the corner near the door. X, Y, and Z dimensions are requested by the software. The device is placed. Using the right mouse click, you can rotate the fire damper if needed. We will now begin locating the center line from the center line of our fire damper by using the AutoCAD Commander line. We are now showing the center line of our supply duct on the drawing. We continue extending our center line to its selected location. It is important to pass beyond the last diffuser with your duct center line. Once our center line is completed, under the C.A.T.S commander under Ventilation, select under Trace Line. Repair Trace Line Global. After selecting the center line, we are creating a trace line. Now we are connecting our diffusers automatically to our trace line. In the AutoCAD command, we are asked to select the diffuser. In this case, we select all diffusers. Next, in the AutoCAD command, we are asked to select the trace line in which the diffusers will be connected. In the AutoCAD command, we are asked whether to connect the diffuser on the top or the side. We will select the top. And now all connections between the duct center line and the diffuser are completed. In the AutoCAD command, we are prompted to select the lines to be deleted. In the C.A.T.S commander, we select Automatic Duct Generation. Under Dimensioning, we will select Round and decide to let the software calculate the sizing of our round duct according to our velocity of 800 feet per minute. We change 600 to 800 in the window. We are now going to assign the round ductwork by highlighting the entire duct system. The software recognizes our center line. The Automatic Duct Generator window has a tab to the right which is labeled Assistant. This is nothing more than a duct calculator. Now all the information is displayed in yellow as the round duct system. We will now select the ducts to be converted from round to rectangular. We will assign our rectangular duct height. We will use the defaulted 18-inch dimension. In width, we will select 0. The software will calculate the duct width according to the velocity. As the air quantity reduces, we now change our duct height to 12 inches. We are now assigning our duct system to a 3-dimensional drawing by selecting a start point at the fire damper. C.A.T.S Ventilation Professional Preferences appears. Under Construction, we can set the maximum length of duct, round pipe, tolerance for fit angle, and rotation angle of round shapes. The others are software default. Under the flange, we have our settings on default. Under Automatic Duct Generation, we have the length of transition set at a maximum of 30-degree offset. Length of rectangular to round transition is 12 inches, and a maximum connection of flexible tube of 36 inches. The next tab is Manufacturing. All specifications are set to SMECNA standards. Select OK. A window appears with a flexible layer management. We will select the layer for supply duct. The software will now create the 3-dimensional drawing. The duct size, width is now created, and we have previously selected our duct height. We will now copy the fire damper. Relocate 5 feet to the left to create our return air duct penetration. We will now draw our duct center line for the return similar to as we did for the supply duct. If your input selections are complete, the C.A.T.S Ventilation Professional Preferences window will appear and will establish the layer for our return air duct system. In the C.A.T.S commander, we will now select a return error register for the duct opening. In attributes for the return error grill, we will revise the value to 1200 CFM. Select OK. You will then select the type of connection to connect the return duct. Select link, select OK. Select the end of the duct to place the return grill. The flexible management layer appears, prompting us to select the layer for this component. Repeat the procedure for the other side of the return. We will now view the 3D design. We can now see that our ducts collide and the fire dampers do not match our generated duct sizes. By dragging the mouse cursor near the duct, the size and elevation of the duct appears. In the C.A.T.S commander, we will select Read Dimension Part. The fire damper window will appear. We will now redesign our return duct at the collision point. We will eliminate the duct section to the right and raise our T 12 inches in the Z direction. We will eliminate the duct toward the fire damper. In the C.A.T.S commander, we will select Angular Cross Sections and choose Offset. The Offset window appears and we select Fit. Select OK. By selecting the flange connections where you want to place the offset, the connection is made. We now want to modify our duct to the left. In the C.A.T.S commander, we will select Redimension Part. We will revise the length of the duct to 6 inches. Select OK. We will now relocate the 6-inch piece to the return grill. We select Offset. Fit was selected previously and we place between the flange connections. For the right side of the T, we will select Transition. Change the second connection to 20 by 12. Link is selected by default. The transition may be rotated by a right mouse click on the fitting. We can see that we still have a collision conflict. In the C.A.T.S commander, we will select again the Redimension Part command. We will revise the T dimension, adding 4 inches. Select OK and the offset now clears the supply duct. We will now add a straight piece of duct to the offset. We will add a transition between the remaining unconnected parts. This can often be the most challenging part of your project due to other trade elements such as electrical conduits, chilled water or refrigerant piping, and plumbing lines sharing the space. C.A.T.S software layer management system will allow you to create each of the materials occupying the space within its own layer. In the C.A.T.S tools, you will find split screen setups. We will select the dual view. You can see we now have on the screen a top and a three-dimensional view of our project. We are now ready to design our mechanical room, beginning by selecting an air handling unit element. We will select the lower left corner of the mechanical room and dimension the location 6 inches away from the corner and 6 inches into the room. When the point is selected, the flexible layer management window will appear, and we will select our layer for the air handler component. Select OK. Using the right mouse click, the air handler can be rotated to its proper direction. We will now select a cooling coil in the C.A.T.S commander. The coil length will be selected at 12 inches. Select OK. The layer management window reappears. We will select, in this case, another layer. The coil is placed. We will repeat this with the filter section. Upon completion of the air handling unit design, we will design a housekeeping pad to be placed below the unit. Here we are giving a height of 6 inches. Dimensions in A and B selection are selected at 6 inches. This will add 6 inches in all directions away from the air handler. Select OK. We will highlight our unit where the pad is to be placed. After selecting the layer, the unit will be raised up 6 inches automatically, providing the space for the pad. The pad is placed. We will begin our design of the ductwork connections from the unit connections to the fire dampers. Here you will view the means of connection that are unique to the C.A.T.S software product. We will begin by placing a transition on the supply air duct flexible connection. By selecting the flex connector, the flexible layer management appears, prompting us to select another layer for supply air duct within the mechanical room. We will now select a rectangular 90-degree elbow. We will place it on the transition. We will now raise the elbow to the same elevation of the fire damper. By selecting center and then by selecting the direction in the Z direction on the C.A.T.S toolbar, we will now select the center of our fire damper. The elbow will now rise to the proper elevation. We will now select duct and fit automatically. We will again select a 90-degree rectangular elbow and place it. We will now move the elbow and center in the X direction to the center of the fire damper. The elbow will be